viewer to our new topic, that is indices and logarithm. When we talk about indices, indices is the plural of the term index. When we talk about the term index, it means the power to which a number is raised. The power to which a number is raised is what we call index. And when we have two or more, we call them indices. So for instance, when we talk about 2 power of 5, 5 is the index and the 2 is the base. 5 is the index and 2 is the base. Some of the laws, we have laws of indices that we shall be using in solving questions in this topic. And before we talk about these laws, there is something you have to understand about the laws of indices. That is, for the laws of indices to hold, the base must be the same. The base must be the same. For the laws of indices to hold, the base must be the same. Like here we have said 2 power of 5. So we deal with more than 1. 2 power of 5, 2 times 2 power of 6, meaning the base 2 and 2 must be the same. If the base are not the same, then the law of indices will not hold. Now, rule number 1 is that n number except 0, whose index is 0, is always equal to 1. N number whose index is 0 is always equal to 1 except 0. That is, 0 power 0 is 0. But 5 power 0 equals to 1. X power of 0 equals to 1. 1 million power of 0 is equals to 1. So anything, n number raised to power of 0 is 1. That's rule number 1 of indices. Rule number 2 of indices, we talk about to multiply. That's multiplication rule. That is when to multiply an expression with the same base. If you are multiplying an expression with the same base, you need to copy the base and add the indices. You copy the base and add the indices. For instance, when we talk about a power of m times a power of n, we copy the base a and then we add the indices m plus n. So it will be equal to a into power of m plus n. Example, like when we talk about 5 squared times 5 cubed, is the same as you copy the base 5, then you add the powers 2 plus 3, which gives you 5. So we shall have 5 power 5, 5 power 5, 5 raised to power of 5, which is equal to 3,125. Rule number 3 is the division rule. That is, to divide an expression with the same base. If you are dividing an expression with the same base, you copy the base and subtract the powers. Like a power of m divided by a power of n is equal to a power of m minus n. You copy the base a, then you subtract the power m minus n. For instance, example here is 9 power of 5 divided by 9 squared would be equal to 9 into power of 5 minus 2, which gives you 9 cubed. Rule number 4. That is, to raise an expression to nth index. If you raise an expression to nth index, we copy the base and multiply the indices. That is, if we talk about a times a raised to power m times n is the same as a mn. That is, if I talk about now, like a, if I talk of if I talk, for instance, about a m, power of m, if this one I raise it again to power of n, this is the same as a, so I take a, I multiply the powers to get m, n, I multiply the powers to a, m, n, it's the same. That is what is, this is the same thing. It's the same thing. Now, example, when we talk about 5 cubed, then squared is the same as 5, power of 3 times 2. The powers are multiplied. So it is 5, 3 times 2, which gives you 5 power 6. 5 power of 6. 5 power of 6. Now, Rule number 5. When dealing with a negative power, to simplify, if you are dealing with a negative power, to simplify, change the power to a positive by changing it into a fraction. You change the power into positive by changing it into a fraction with 1 as the numerator. For instance, when we talk about a, power of negative m is the same as 1 over a power m. So that means you reciprocate the same. We can also talk about, for instance, because I've said you find the reciprocal. So if I talk about a over b, if I talk about a fraction like a over b, power negative n, power of negative n is equal to change the power into positive, you find the reciprocal is the same as b all over a, that is the reciprocal, then the power now becomes positive. Power of n is the same, power of n. So it is b all over a power of n. So we can talk about this. You can go work with this. That is a raised to power n, m, negative m, is the same as 1 over a power m. Or if it's a fraction, that is a over b, power of negative n is the same as b over a power of n. You change the power into positive. So we shall use these two to solve questions. You can either use this if it is in fraction form. You can either use, if it is in fraction form, you use this one. And if it is not in fraction form, it's just like this, you use this formula. Like example here, 2 raised to power of negative 2 is the same as 1 over 2 power of 2, which is the same as 2 power 2 is 4, 1 over 4. Like if you are given 2 cubed times 2 power negative 3, this is the same as, we take the base from the laws of multiplication, we take the base to be 2, then we add the powers, which is 3 plus negative 2, negative 3 I mean, which is the same as 2 raised to power 3 minus 3. Because negative times positive is negative. And this gives you 2 raised to power 0. And our first law, or our first rule, we said that n number whose index is 0 is equal to 1. We said is equals to 1. So that is how you solve that. And if you are given a fraction like 2 over 3 raised to power negative of 2, I've said the simple way is you find the reciprocal, then you change the power into positive. Like now it becomes 3 all over 2, 3 all over 2, then you change the power into positive squared, which is equal to this 3 over 2. 3 over 2 gives you 3 squared is 9, 2 squared is 4 over 4. Simple as that. Or you can use, or we can use, that is all. We can use the other way that we said, it will be 1 all over 2 over 3 now. 2 all over 3. Now the power becomes positive. 2 all over 3 power squared, which is equal to 1 all over 4 all over 9. Meaning it is 1, which is equal to 1 divided by, which is equal to 1 divided by 4 over 9. 4 over 9. And we know how to do it, which is equal to 1 times 9 all over 4. And this will give you 9 all over 4. And this will give you 9 all over 4. So we can either use this method or this. This is cheaper and it's faster. So when it's a fraction, but this one only applies when it's a fraction. This applies for both. This applies only when it's a fraction, and this applies for both. So that is the simple way of applying those rules. And then as we continue with another example, there is another example. Now you understand how to apply those laws. You understand how to apply the laws. These laws, if you understand all of them, then solution on questions on indices will be easier for you. So you need to understand all the laws from the first one to the fifth one as I've given you before you are able to solve equations. Let's talk about fractional indices. Fractional indices are written in fraction form. These are indices written in fraction form. So in simple terms, when we talk about if a power of n equals to b, then a is called the nth root of b. A is called the nth root of b and is written as nth root of b, like it is here. So for you to understand better, if I use a number like, let's talk about 5. If I use a number like 5 squared, 5 squared we know equals to 25. So that you understand what I mean, equals to 25. So that means if I want 5, like I said, a power of n, so 5 squared, a power of n, so n is 2 and a is 5. So if you need a is the nth root of b, a is the nth root of b, so 5 is the 5. So this implies that 5, to get 5 we find the square root of 25 because it's squared. Now to get 5 is the square root of 25. 5 equals to square root of 25. 5 equals to the root of square root, it's the root of 25, and that is true. 5 equals to the root of 25. So that is what we mean, that if a power of n equals to b, then a is the nth root of b. So for instance, example here, if you are given 25 power of a third, this means we find the cube root of, because remember root is like a half. Now 27 a third is the same as we find the cube root. It's the same as we find the cube root of 27. And the cube root of 27 we know is 3. That is 3 times 3 times 3 gives you 27, is 3. The cube root of 27 is 3. And then when we talk about 16 power of 3 over 4, meaning you find the fourth root, then you cube. This is the same as fourth root, because a fraction of 4 is the fourth root. This is the same as the fourth root of 16, the fourth root of 16. Then all this is cubed, or this is cubed, which gives you the fourth root of 16 is 2. That is 2 times 2 times 2, 4 times, gives you 16. So the fourth root of 16 is 2, and then is also cubed. And that gives you 8. That gives you 8. 2 cubed is 8. 2 cubed is 8. So if you understand how to apply the fractional indices and those laws up to number 5, then you are able now to solve any question from indices. We shall do questions later. But now we continue with another subtopic that is on logarithms. When we talk about a logarithm is the power to which a fixed number, that is the base, must be raised to produce a given number. It's the power to which a fixed number, that's the base, must be raised to produce a given number. That is, in summary, when we talk about a power of m equals to n, this can be written, this is the index form. The index form, like we have said, or the index notation, can be written in logarithm form as log of a. Now we take n, log of base of a of n, log base a of n, log base a of n equals to m. So m we take it on the right hand side. So it will be log of base a of n, log base a of n equals to m. Log base a of n equals to m. So when talk about, for instance, example here in the index notation and logarithm form, we talk about 2 squared equals to 4, meaning that log to base of 2 of 4 equals to 2. Log to base of 2, you take 4 here, you take the power here. So log to base of 2 of 4 equals to 2. Log to base of 2 of 4 equals to 2. Like if we talk about 9 power of a half equals to 3, so that means log to base of 9 of 3 equals to 9. Log to base of 9 of 3 equals to a half. Log to base of 9 of 3 equals to half. Log to base 9 of 3 equals to half. This one will be log to base of b of m equals to n. Log to base of b of m equals to n. So that is how we do we change index notation to logarithm form. Now we need to know how to read reading logarithms from the table. How do we read logarithms from the table? The same way we were reading square roots and reciprocals from the table, that is how we do with logarithm. That is, we can read the logarithm of number between 1 and 10 directly from the table. And for numbers that are greater than 10, we proceed by writing the numbers into standard form, like a times 10 to power of n, a times 10 to power of n, whereby n will be the whole number part of the logarithm. So n that you get will start as part of the logarithm that you are going to write down. The n becomes part of the logarithm that so the log of that number becomes n point. Then you read from the table. For instance, find the logarithm of 379. How can we read the logarithm of 379 from the table? So the first thing we do, we write this because it is now not between 1 to 10. It's not between 1 to 10, and we cannot read logarithm of between 1 to 10 from the table directly. Now that it's not between 1 to 10, we write this into standard form. It will be 3.79 because we count 1, 2 up to here. When we move to the left, the power is positive, and when we move to the right to the first number, whole number, when we move to the right, the power is negative. Like now here, we move to the left to 1, that is 1, 2. So it will be 3.79 times 10 power of 2. Now our logarithm will always start with 2. But what we do, remember logarithm from the table are into the base of 2. So that if they are into base of 10, not 2. Logarithm of numbers from the table are in the base of 2. So whatever you read from the table is in the base of 2. So that means when we talk about this one, we will find the log of this, then times the 10 squared. So what we do, the log of this will be in the base of 2, 10 times 10, will be in the base of 10, then times 10 power of 2. So that means I read this from the table, 3.79. I'll find 0.5786. How do you read from the table? 3.79. 3.79, you go into your table. If this is your table here, you read 3.79. So sub 3.7 you realize is here. 3.7 is here. Some others will write in form of points and others will write in form of honor. But these are points because it must be between 1 and 10. So this is 1.0, 1.1, 1.2, 1.3, and now we are talking about 3.79. Remember, we are talking about 1.79. So you read 1.7, you go to the column of 9, 1.7, 3.7, you go to the column of 9, you go close up to the column of 9 here, you find this point. Remember, it's point. Because all these are 0.04, so we are talking about 3.7. You go to the column of 9, you read as 0.5786, 0.5786. So after you find 0.5786, that's the log of 3. So that means that we write now them. If we write them in the form of base of 10, because we know this we write in base of 10 because this is the logarithm of 3. So this times this is equals to this times this is equals to, it's the same as this one. Now the log of this is what? Is 10. Base of 10, we have found it to be 0. Power of 0.57 power of 0.5786. 86, 57, 86. So if that is the power, then remember times 10 squared, times 10 squared. Now that we have the base, the same base 10. Remember all logarithms are in the base of 10. Now that we have the common base of 10, and from the laws of indices, we said the laws of multiplication of indices, we said if they are multiplied, then we have the same base, we add the power. So we shall add the power 2 plus 0.576, which gives you this as your logarithm of. This will be the logarithm of 379 is 2.5786. You add the 2. Remember 2, the whole number part is what we call the characteristic. We call it a characteristic. 2, we call it a characteristic. And this 0.87, that is 50.5786. We call it a mantissa. 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 This we call it a mantissa, and the 2 is a characteristic. We call it a characteristic, and this is a mantissa. So that is how we find the logarithm. If you are asked to find the logarithm, maybe in terms of calculating, but when you go further, you realize that you need not to write all of this. You need not to write all of this unless in an exam situation you are just asked like 379 alone, you find the logarithm. So you have to show this one so that you at least score the 2 marks or the 3 marks that you are given. But if you're not asked that, we shall learn further on how to just do without writing 10, base of 10 and all that, unless it's just one number you are asked to find the logarithm. So you have to show the process. But if not, you just calculate. If you are given a question like for this one, it was straight 3.79. What if you are given like let's say you are given a number like you find the logarithm, you are asked to find the logarithm of a number like let me use the same number. Assume you are given to find the logarithm of 3,796. You're asked to find the logarithm of this. Now what you do, like I said, the first thing is to write this into standard form. So the standard form is 1, 2, 3. I'm moving to the left. So it is 3.796 times 10 power of 3. Power of 3. Now we find the logarithm of this. So the log, we find the log of 3.796. To find the log of this, we go to the table 3.79. Remember 3.79, we were able to find it as 0.5786. 3.79. The log of 3.79, 3.7 is here to the column of 9. The column of 9 is here. You find 5786.5786. Now we go, because there was a 6 here, so we go further and look 0.576. You write it down, and then you look at 6, the column of 6 here with the same 3.7. You go across the column of 6. The column of 6 is here. So you realize the number is 7. So the 7, we come and add it here. We add it here. So we shall have the log of this will be equal to, now we have said, we have found 0.57, 0.5, okay, 0.5, 0.5786. Then you had on the column of 6, on the other side, you had what we found. We found it to be 7, if you were able to follow. So you add the 2, you get 13. This is 3, carry 1. So this gives you 9. This gives you 5, 7, because it's just 7.0. So that is the logarithm of this. The logarithm of 3.796 is 0.5793. So when you get this, now we come and we said this logarithm is in the base of 10, 0.5793, then times base 10 the power of 3. So we will add these, the bases are the same, we add the powers. So the logarithm of the whole number, the logarithm of this number, the logarithm of 3796 is equal to 3 plus this gives you 3.57 3.5793. So that is, this is the logarithm. This is the logarithm. The logarithm of 3796 is 3.5793. So that is the logarithm of this number. The logarithm of this number is 3.5793. So you should be able to find logarithm. That is how we use the table to find logarithm, and then we shall be using all the time. I know some of you use calculators, but if you are told to use a table, just use the table, because sometimes the calculator does not give you the accurate answer, does not give you the exact answer that is there in the table. So if the examiner wanted you to use the table and you have used a calculator, sometimes the examiner might realize, I know you count using the calculator the 4 significant figures, then you are able to round off if necessary. But you remember, some of them, if you do them practically, some of them does not give exact figures as the table. And if it does not give exact figures as the table, you realize that the examiner might not give you the marks as required because you have not got the answer. So if it had 4 marks, you might get 3 instead of 4. So it's good that you read what is in the table and not what you find by using the calculator. And not what you find by using the calculator. And not what you find by using the calculator. So that is how we read. That is how we read using. That is how we read using mathematical tables. Now let's talk about logarithm of positive numbers less than 1. Logarithm of positive numbers less than 1. Like we have a positive number less than 1, like 0.034. Like I said, you write it in standard form, it will have a power of negative. And the power of negative, we write it in logarithm form as par. We call it par. That is, the negative is written directly above 2. That is, the negative sign written directly above 2. That shows that it is only the characteristic is negative. Only the characteristic that is negative, but the logarithm is not negative. So we call it a par. A bar is written above the 2 to show that it's only the characteristic that is negative. And it is not the whole number that is negative, only the characteristic that is negative. And that is why I usually encourage my learners that you should not use a calculator. Like if you are multiplying this with 2, you should not, or you are adding with 2, or you are adding with a certain number, don't use a calculator direct, because if you use a calculator direct, or you are dividing, if you use a calculator direct, then you will not get the required answer, because you get a wrong thing. So usually I advise people that you just do it manually. If it's multiplication, as long as it has a negative characteristic, because it is only the characteristic that is negative and not the whole number. So, like this one, you count 1, 2, it would be 3.4 times 10 power of negative 2. 3.4 times 10 power of negative 2. So, we look for the logarithm of 3.4 from the table. Now you know how to look for the logarithm. You will find it as 0.53 15, then times 10 power negative 2. So we shall have, we add now the powers, power of negative 2, you don't write it as negative, you write it as power 2 plus 0.5315. Now we add the characteristics separately. So if you add the characteristics separately, the characteristic is negative 2 plus this 0 gives you negative 2. So negative 2 point, then you also have 5315. 5315. So it will be power 2.5315. That is how we find the logarithm. Like this one, we need to find the logarithm of 6.3. Now we write this into standard form. That is an example. Find the logarithm of this. We write this into standard form. The standard form of this, remember, I move 1, 2, 3, 4. It will be 6.3 times 10 power of negative 4. So I read the logarithm of 6.3 from the table. If I read the logarithm of 6.3 from the table, I go into my table and read 6.3. Okay, this table doesn't have, so I read from my table the logarithm of 6.3. If I read the logarithm of 6.3, I'll find it to be 0.7993. 0.7993 is the same as 0.7993993. So after finding 0.7993 as my logarithm of 6.3, now I will have now the logarithm of this as the logarithm of, so the log of 0.00063 would be equal to 10 base of 10. That's the logarithm of this 6.3, which is 0.7993, then times base of 10 negative 4. Now I had now the powers, which will give you power 4. I said the power to show that it's only the characteristic that is negative. Sorry. So it will be power 4 plus this one, which gives you power 4 point. If you add this one, 0.7993. So that is how we find the logarithm of a number like this one. That's how we find the logarithm of a number like this one. That's how we find the logarithm of such a number. Now we need to know on how to find anti-logarithm of numbers. How to find anti-logarithm of numbers. Now we're going to talk about anti-logarithms. Now finding the anti-logarithm is the reverse of finding logarithms. For instance, when we talk about logarithm of 1000 to base of 10 is 3. So that means that anti-logarithm of 3 is 1000. So in simple terms, when we talk about the logarithm of x equals to y, then the antilog of y is x. Antilog of y is x. So like for instance, we are asked here to find the anti-logarithm of this. Now remember, we go the reverse from where we left. In your table, there is antilog. You read the same way you were reading on. The antilog has point something. It starts with 0.30, 0.10. So you start with the 0.1 something, 0. You continue reading from your table. Like now we find the antilogarithm of this. So the antilogarithm of this, the first thing is that we let the number to be x, or in simple terms, and logarithm of this, if we let the number to be x, that's the logarithm of this to be x. If we let the number, we let the number to be x. We let the number, if I let the number to be x, if I let the number to be x, so that means to get this x, remember this is 10, -2, then times 10 -2. First of all, remember this was 10 -2 because when you are coming to get these characteristics, you took this to be per 2, then point. Now we find the anthrog from the table of 0.30, so that we multiply with this. So our x now becomes 10 power of -2 times, we read anthrog of 0.303, then you add the other side 1. So 0.30, you go to the column of 3, then you go the other side 1, you add, then you find your anthrog of 0.3031. So if I find the anthrog of 0.3031, I'll find the anthrog of 0.3031 to be 2.00, if you make a mistake here, this is now where the mistake comes. If you use a calculator, you'll find it to be 2.01. That is by using the calculator, 2.01. But if you use your mathematical table, you'll find it to be 2.009009. That is by using a mathematical table. But by using a calculator, you'll find it 2.0095. So that means the 5 changes this 9 to be 10. And then carry 10 is 0, carry 1. You'll find it to be 2.010. That is by using a calculator. But by using a mathematical table, you find it to be 2.009. So you realize there's a difference sometimes. It's not all the cases that the calculator gives you exactly what you wanted or exactly what is in the mathematical table. So this is the number. You know how to change it. Remember, negative, you went to the left side. So if I go to the left side, I'll add a 0 here because I'm 2 steps behind. If I add a 0 here, it will be 1 with this 0 again 2. If I added a 0 here, I move 1 2, so it will be negative. A point should be here, so it will be equal to, because times 10 -2, it will be equal to 0.0 now 2009. So this is how we find anthrog. Now, after understanding how to find the anthrog of numbers, then now you should be able to solve questions using mathematical tables. You are able now to solve questions using mathematical tables. Now, I will show you on how to solve question using mathematical tables. How to solve questions using mathematical tables. We want to see on how to solve questions using mathematical tables. We start with our first example here. Use logarithm tables to evaluate this. So what we do, if you are asked to, we write number, we make a table of number, standard form, then we talk about log. We talk about log here. I also write another log here. I'll show why I've written 2 logs. Like 456. My number is 456. Standard form will be 4.56 times 10 raised to power 2, because I've moved 1, 2 raised to power 2. So my logarithm must start with 2, like I said, 2 point. Now you read the logarithm of 4.56 from the table. Logarithm of 4.56 from the table. You read the logarithm of 4.56 from the table. You will find it as 0.65, 0.65, 0.6590, 0.6590, 0.6590, 0.6590. You'll find 0.6590. Now there is a times. Remember the powers, logarithms are powers, and when powers, both of them with base of 10, and then when there is a multiplication you add the powers, and when there is a division you subtract the powers, because they have base of 10, both, all of them. All logs are in the base of 10, so bases are the same, and then you add the powers, you subtract the powers when it is a division. So we take 398. If I take 398, if I take 398, standard form it is 3.98. I move 1, 2, it's 3.98. 0.98 times 10 raised to power 2. So the logarithm must start with 2 point. Now I read the logarithm of 3.98 from the table. 3.98 logarithm of 3.98 from the table. You'll get it as 59. 59.99. You get it at 59.99. 59.99. Now, first of all, before we deal with this one, there is a multiplication. So I added the 2. So that you see why I was writing this. Log and log, so that whatever the log I get in manipulating here, I take it this side. Then if there is also another manipulation on the denominator, I do from this side and then I take it. So that because there is a division, now I subtract the 2 logs on this other side. So that is why I'm using log. But even if you use log and then you do everything here, it's still okay. But I prefer using log and log so that I transfer the same log. Like now I add here, I will find 9. Add it manually. This is 18. You write 8. 18. This is 18. I write 8. I carry 1. So it will be 15. 9, 10, 15. I write 5. I carry 1. This is 11, 12. I write 2. I carry 1. I write this point here. So this is 4, 5. I will have 5.2589. So I'll have to bring this other side, 5.2589. If I bring it this other side, now I come and deal with 271. I deal with 271. Standard form is 2.71. 2.71 times 10 raised to the power 2. So the logarithm must start with, because there is no manipulation, I could have written here, if there was the squared, for instance, if it was squared, I could have written it here first, then I multiply by 2, because we said when the powers with another power, you multiply the powers. But there is no another manipulation here, so I take all these, the logarithm of this, I take it this other side, it will be 2 points. I read the logarithm of 2 because the logarithm must start with now 2 point. I read the logarithm of 2.71. The logarithm of 2.71. If I read that logarithm of logarithm of 2.71, I will find that it's 4330. I'll find that 4330. I'll find it to be 4330. I'll find it to be 4330. And because there is a division in this case, I subtract this and these are divided, so I subtract the logs. I'll find it as 9. I'll find it as 9. I'll find it 9 minus 0 is 9. Then 8 minus 3 is 5. Then 5 minus 3 is 2. Here is 2. 2 you cannot deal with 2 minus 4, so I make it 12. 12 minus, I borrow 1 from here, we remain with 4. I have remained with 4. Then I have 12 here. 12 minus 4 is 8. Point. Now we have 4 minus 2 is 2. So 2.8259. I now need to find the antilogarithm so that I get the x. I get the x. I get the number. I find the antilogarithm of this. And the antilogarithm will be times 10. Times 10. The antilogarithm will be times 10 raised to power 2 times 10 raised to power 2, these 2. Now I find antilog of 0.8259. 0.82 you go to 5, then you go to the 9 the other side, and then you add. So antilogarithm using your mathematical table. So we find the antilogarithm. We find the antilogarithm of 0.8259. You will find it to be 6.697. 6.697. You'll find it to be 6.697. 6.697. You find it to be 6.697 times 10 raised to power 2. So if I move to power 2, I move now 2 steps. So the number is that is our answer, which is x now. That's x. We are looking for x. X is that is the number is 1 to 669.76. The number is 669.7. The number is the number 669.7. 669.7. So that is the number. A question like this, evaluate 415.2 times 0.061 divided by 135. So you still write the number. You write in your table standard form. You write log. You can write another log here. Now I talk about once you make such a table, 415.2, the number is 415.2. Standard form, I move 1, 2, it will be 4.15, 4.152 times 10. Remember, I moved 1, 2 to the left, power of 2 positive. So the logarithm must start with 2 points. You read the logarithm of 4.1, then you go to the column of 5, and then the other side you look at 2, you add. So if I look at the logarithm of 4 point, that logarithm of 4.15, then I go to the other side 2, I add, it will give me 6183. Now, because there is a multiplication, I deal with a number from that is multiplied. That is 0.0761. 0.0761. I deal with the 0.0761. So I write standard form. I remove 1, 2, and this is the first number, whole number here, which is 1, that is significant. So it will be 7.61. 7.61 times 10 raised to power negative 2. I've moved 2 steps, power negative 2 to the right. So it will start with power 2 point. Now I read the logarithm of 7.6, then 1 at column 1, logarithm of 7.6 at 1, logarithm of 7.6 at 1, you will find it to be 8814. 0.8814. Now remember, this is a multiplication, so we add. These are powers, remember, of base of 10, so we add. They are powers of base of 10, so we add. So if you add this and this, you get 7. You add this and this, you get 9. You add this and this, you also get 9. You add this and this, you get 14. You write 4 carry 1. You put a point there. Now 1 plus 2 is 3. 3 plus minus 2 is the same as 1. It's the same as 3 minus 2, which is positive 1. So it is 1.4997. 1.4997. Then on the numerator side, on the denominator side, I mean, we have 135. So you write that number 135. You write 135, the number 135. It will be 1.35 times 10, 1.35 times 10 times 10 raised to power 2, because I moved from the right to the left, 1, 2. So I start with power of 2, 2 point. I find the logarithm of, okay, it's good, like I said, I bring this other side so that to avoid my confusion, to avoid confusion, I could bring this one, here, okay, I could bring it as 1.4997. Then I read the logarithm of, remember it will start with 2, so it will start with 2 like I've said. This one logarithm will start with 2 point. I read from the table logarithm of 1.3, then at 5, the logarithm of 1.3 at 5, then you read that, you get 0.1303, 0.1303, 0.1303. And remember it is division, so I subtract, because this and this is division, so I subtract. I get this minus this, I find it as 4. Then 9 minus 0, I find it as 9. Then I also have 9 minus 3, I find it as 6. Then I have 4 minus 1, I find it as 3. Then point 1 minus 2, I find it as -1, so I write power 1 because it's a characteristic. Power 1. So I need the number. I need the number x. So my x will be equal to times 10 power of -1, 10 power -1. That is my x is 10 power of -1, 10 power of -1, because I multiply with this. You find the logarithm of this, you multiply 10 power of -1, 10 power -1, then times antilogarithm of this. You find the antilog of 0.369, then on the other side 4, then you add. So the antilog of 0.36, the antilog of 0.36, then at 9 you read the other side 4, and then you add. You will find them as 2.341. 2.341. You find it to be 2.341. Now you multiply this. Remember, it is one step behind, so it will be 0 point. So my x, so that means my x, so that means my x will be equal to 0.2.2341. 0.2341. So that is how you solve. This is how you solve using logarithms. This is how you solve using logarithms to find logarithm of numbers. This is how you solve to find logarithm of numbers. Let me deal with a question that is concerning a square root. A question involving a square root. Let me deal with a question involving a square root. A question involving a square root. I deal with a question involving a square root. I deal with a question involving a square root, so that you also know on how you find if the power is a half or if the power is a fraction. So that is like you're dividing with that number, and you realize how you do it with a negative characteristic. I'll show you. So let me deal with a number like this one. If you are asked to find the logarithm of that, like we were doing, so the first thing we said is that you write the number, then you write the standard form, then you write log, you also write log. So if I have such, like it is 0.945, 0.945. Standard form is 9.45. Standard form is 9.45 times 10 raised to power -1, because you have moved one step to the right, times 10 power -1. So the logarithm starts with power 1 point. Now I read power 1 point. I read the logarithm of 9.45. I read the logarithm of 9.45 from the table. 9.45 from the table. I find it as 97.54. 97.54. 0.9754. Now, because there is a square root, remember now you are done with the number, but there is a square root. So because there is this square root, if it was squared, or this was squared, then it could be times 2. But it's square root, meaning the power is a half, so it is times a half. So times a half is the same as I divide by 2. It's the same as I divide by 2. Now when you are dividing by 2, what you do, if you are dealing with a negative characteristic, you first of all make this negative. So if I make 2 negative, I think of what I can add to 2 to make it -1, to -2 to make it -1. So if I think of -2, because I have made this negative, plus if I have +1, this gives you -1, which is this. So in case that does not work, of first of all changing that division, if it was a quarter, that is the 4th root, so it was divided by 4, or times a quarter. So that means I first of all, if it was 4th root, I first of all make 4 negative. Then I was to think, and if it was -1 here, so I was to think how I can, what I can add to -4, I could think what I can add to get -1. So if I had 3, it could be, if I had 3, it could give me -1. So in case it was a 4th root, then I could have dealt with these numbers. But now what you need to realize that when you are dealing with that, like now this one, I have said I'll make this negative. I had 1, it will give me at 1. So that 1, I separated them. It's good to separate them when you are dividing, such that I now have, like I've said, I make -2. I say over 2, then plus, I separate them because I said I had 1, so plus 1 point, I write all that, 97.54. It's good to separate all over 2. Say that this is the characteristic. You divide the characteristic separately and this other one separate. So if I divide this, I get the characteristic as power 1. then I add plus whatever you get here. That is, if I divide 1.9754, I divide by 2, I'll get 0.9777, 0.9877. So if I add here, it will be 0.9877. Now, so that means this is what I was to transfer here, because I was doing with the manipulation on that other side. I transfer here per 1.9877. You find the nth log of this to find x. So the nth log is times what? Times 10 power of negative 1. I look with the nth log of 0.9877, the nth log of 0.987 and 7 on the other side, then you add. So that is nth log of 0.98, you look at 0.98 and then at 7, then 7 the other side, so that you add, you get it to be 9.721. 9.721. 9.721. So this means that my number x is, so my x that I was looking equals to, my x equals to nth log of this one I found it to be 9.721. So my x is, if I move one step behind it, will be 0.9721. 0.9721. So that is how we do it. And if you checked that, from your calculator, that is the square root of 0.945 is 0.9721. So that is true. So that is how you solve by using logarithm. That's how you solve by using logarithm. Now we need to note that in order to divide a power of 1 point this by 2, we write the logarithm in such a way that the characteristic is exactly divisible by 2. If we were looking for nth root, we arrange the characteristics to be exactly divisible by n, like I explained from above, that you make like this one. So I will ensure, remember this is divided by 3, so I'll ensure that the negative, I'll start with negative 3 plus whatever that gives you that characteristic, like I've explained from above. So I want to do this as another example to explain the same concept. I do the root, cube root. I do one involving the cube root to explain the concept, well. So if I deal with the cube root, like this question, you find the cube root of 0.0618. So like I said, we write the number, we write standard form, then I write the log, I find the log, and then I also write log. The second log is for my easy manipulation. You make such a table, then you write the number is 0.0618. Standard form will be 6.18. You've moved 2 steps to the right. 6.18. You've moved 2 steps to the right. So it is times 10 power of negative 2, because you moved 2 steps to the right. So the logarithm starts with per 2 point. You read the logarithm of 6.18 the logarithm of 6.18, you find that logarithm to be 79, 7910 to be 7910. You find it to be 7910. You find it to be 7910. Then, because it is a cube root, so that means times a third, so it means you divide by 3. So it means you divide by, so that means we divide by 3. Like I said, we look for number, like I make this negative, I think what can I add to get negative 2? So if I make 3 negative, it will be negative 3 plus, because it is divisible by 3, negative 3 will be divisible by 3. So plus 1 gives you negative 2. So I'll make it negative 3 because it's divisible by 3 all over 3. That is plus, that is by 3 all over 3. Then plus, I said plus 1 gives you negative 2. Negative 3 plus 2 plus 1 gives you negative 2. So it gives you the characteristic. So plus 1.7910 divided by 3. I separate like I told you. This gives you power 1. That gives you power 1 plus this. So you divide that 1.7910 divided by 3. It gives you 0.597. So 0.597, remember it now becomes power 1.597. Now you also, so if I transfer this here, if I transferred it there, if I transferred it here, it becomes power 1.597. So I look for my, if I look for my x, I'm after my x here, the number. If I look for my x, it implies that my x, the number is what? Equals to, remember the standard form will be times 10 power. So whatever I get, that is 10 power of negative 1 times the nth log of 0.597. You look at 0.59 nth log of 0.597. 0.597, the nth log gives you 3.954. 3.954. It gives you 3.954. So that means times 10 power negative 1. So negative 1, you move one step behind, it gives you x as what? X as 0.3954. It gives you that as the value of x. It gives you that as the value of x. Now, having understood all about logarithms and indices, I want us to do some questions to make our understanding better. I want us to do some further questions to make our understanding better. Now, like if I ask you that some questions that is solve for x in 9 power of x plus 3 power of 2x minus power of 2x, then minus 1 equals to 53. So the first thing you do is this negative 1, you take it to the right hand side. If I take that negative 1, that is the solution here. Solution. I take 1 to the other side, it gives me 9 power of x plus 3 power of 2x, which is equal to 1. The other side becomes positive, so 53 plus 1 becomes 54. Now what I do here, this base of 3, I can make 9 the base of 3, so it becomes 3 squared. Remember, this all was power x plus 3 power 2x equals to 54. If I write this, remember I used some laws of indices of the nth power, so it is 3 power 2 power of x. So you multiply the powers, it gives you 3 power 2x, it gives you 3 power 2x plus 3 power of 2x power of the x, which is equal to 54. So this is 3 power of 2x and this is 3 power of 2x, it's the same. So what I do, I'll have to say like I let 3 power of 2x, if I let 3 power of 2x to be equal to y, if I let it to be equal to y, so that means y plus y, it implies that y plus y plus y plus y equals to 54. That means that 2y equals to 54. I multiply by 2, so that means my y equals to 27. 54 divided by 2 you get is 27. So y is 27. My y is 27. So that implies that I can easily now substitute y with 27. So meaning that 3 power of 2x, 3 power of 2x equals to 27. 27 can be rewritten in the base of 3. That is 3 cubed gives you 27. 3 cubed gives you 27. So that means I can write and say if I write this gives you 3 power of 2x, 3 power of 2x equals to 3 cubed. There is an equal sign and the base are equal. If the base are equal, that means the powers are also equal. If the powers are equal, it implies that because the powers are equal, it implies that 2x equals to 3. I divide by 2. These 2 and these cancels, so I remain with x equals to 3 over 2 equals to 3 over 2. So that is how you solve such a question, equals to 3 out of 2. So that is the value of x. That is the value of x equals to 3 over 2. That is the value of x. That is the value of x. The value of x. So that is how you do to find the value of x. That is how you find the value of x. Now let us look on a similar question, but we also apply those laws. If you understood the laws well, you'll be able to get all the questions correct. If you understand, this looks almost similar, but there is something that might be different. Like now, I make this the base supposed to have the base of 3. So I will be 3. It will be 3 squared. Remember, 3 squared is 9. 3 squared into now x plus 1. X plus 1 then plus, because there is an addition, 3 into power of 2x plus 1, this is equal to 36. That gives you 36. This gives you 36. Now this gives you 36. Now what you do here, if you open, you make this, it will be 3 power of 2x. 3 power 2x, you open that bracket. 2x, 2 times x is 2x plus 2, plus 2, then plus 3 power 2x plus 1 equals to 36. Now, what you do, remember this is an addition. If there is an addition, first of all, we can just leave the addition the way it is. But what has happened here, there is a base and the powers are added. If the powers are added, that means this was multiplication with base of 3. So that means I can write this to be 3 power of 2x, because there was a multiplication that occurred, then times 3 squared, because if the base are the same, then that means you take the base, then you copy the base and add the powers. So it is 3 power 2x plus 2. You get the same thing. So plus, the same apply here, it will be 3 power of 2x times 3 power of 1, which is equal to 36. Now here I can let 3 power of 2x to be y. If I let 3 power of 2x to be equal to y, then that means I let 3 power of 2x to be equal to y, so that means y times 9, that is this 3 squared is 9, so it gives you 9y. So that implies that 9y, it will be 9y plus, this is 3, this is y, so plus 3y, which is equal to 36. So 9 plus 3 gives you 12y. 12y equals to 36. Now I divide by 12. So 12 and 12. So that means that my y equals to 12 divided by 36 divided by 12 is 3. So y is 3. So that means if y is 3, that means, or that tells you that, so that tells you that I substitute with 3 power of 2x, 3 power of 2x, that's what it means. It implies that 3 power of 2x equals to y, which is 3. 3 is the same as 3 power of 1. 3 power of 1 is 3. So base now becomes equal and the power will equalize. So that implies that 2x equals to 1. Powers are equal. So if they are equal, you divide by 2, So that means my x equals to a half. My x equals to a half. So that is how we find the value of x in such a question. The value of x in such a question. Now, let me do some. I may not do all the question. Now, how do we find like a question like this one? Given that 6 power of 2n minus 3 equals to 7776, that's 7776, we can think on how we can make this to have the base of, we can think on how we can make 7776. 7776, can I make it to have the base of what? To have the base of 6. Let me try. You write 7776. If I think of dividing by 6, if I divide by 6, 7776, if I divide by 6, I'll get 1296. I'll get 1296. I divide still 1296 by 6. If I divide by 6, I get 216. If still I divide by 6, what do I get? 216 divided by 6. If I divide by 6, I get 36. And if I divide by 6, if I divide by 6, I get 6. If I divide further by 6, I get 1. Now I'm done. So that means I have 1, 2, 3, 4, 5. So 6 power of 5 will give you this. So that means, this means that this number 6 raised to power of n, 2n minus 3 will be equal to, this number is 6 raised to power of 5. And because the bases are the same, the powers will be equal. So that means because the bases are equal and the powers are equal, because there is an equal sign here. So that means that 2n minus 3 equals to 5. I take 3 the other side, it will be added, so that means 2n will be equal to 5 plus 3. 5 plus 3. So 2n equals to 8. 2n equals to 8. 2n equals to 8. So that means (2n) equals to 8. I divide by 2, I divide by 2. So that means that n, because this cancels, so I remain with n equals to 4. Equals to 4. N equals to 4. So that is how we find the value of n here, by just understanding those laws of indices. Now a question like this one, how do we find the value of n? I need this value of n. So what I do, for me to find that value of n, I need to find the value of n in this other side. I need to find the value of n. The value of n I need to find in this question number 4. I find the value, given that this is this, find the value of n. Now what do you do? Remember, I have talked about this this law. So this law that I've talked about, this is cube root. Cube root, it means this is the same as cube root is the same as 9 power of 4 and then brackets, there is a cube. A cube root is the same as a third, which is equal to 3 power n. Now first of all, if I open this bracket, I do what? I multiply the powers. So if I multiply the powers, remember this I can write as 2 squared. This one can be equal to 3 squared. So 3 squared This is 3 squared power of 4. This can be 3 squared, first of all, power of 4, 3 squared power of 4, and then again, okay, let me use this, power of 4, and then power a third, which is equal to 3 power of n. So this gives you 3 power of 8. This is 3 power 8, because you multiply the powers from the laws. Then that one is also power third, which is equal to 3 power of n. Now you open, it gives you power of 8 over 3. So it gives 3 power of 8 all over 3, 3 power of 8 over 3, 8 all over 3, which gives you 3 power of n. The bases are the same and the powers are equal, so that means my n equals to 8 over 3. So my n equals to 8 over 3. So that means my n equals to, it implies that n equals to 8 over 3. N equals to 8 over 3. So that is how we find the value of n in such a question. That's how we find the value of n in such a question. The value of n in such a question. Now you understand on how to apply indices. I'll do some questions also on how to apply a logarithm. But before I talk about on how to apply a logarithm, you need also to note, if you are given a question like this, two numbers p and q are such that p cubed times q equals to 189. So you must think on how you can write this question in a number cubed times another number. A number cubed times another number. So what I'll do, I'll think on how I can write 189. If I think of 189, I'll start thinking about, first of all, what if I think of 3, or now I divide by 3. You start with 2, but 2 cannot go there, so you start with 3. 3 can go there, 189. If I divide by 3, I'll find it to be 63. And 63, I divide by 3. 63, if I divide it by 3, it can also give me 21. If I divide by 3, it gives me 21. This 21, if I divide by 3, it gives me 7. So that means from there I cannot proceed. So that means this number 189 I can write it as, so that means my 189 I can write it as p cubed times q equals to 1, 2, 3, 3 cubed times 7. 3 cubed times 7 gives me 189. And therefore means that my p, because p cubed times q, my p, therefore my p equals to 3. And my q equals to 7. So that is how simple you are supposed to do such. Now, I want to discuss on how logarithm we have discussed, but let me do one question on this, so that I leave other questions for you to do. I do one question on this, then I leave others to do on logarithms. I leave you some others questions to do on logarithms. So what I do in such scenario, what I do, like here, I'm told that I find question number 6. I use logarithm correct to first significant figure to evaluate this. So we said you write number, you write standard form, you write log. I was also writing another log here for the reasons I explained to you. So you have such a number, you make such table, it's very necessary. you make such table is very necessary. Then you start with 72.56, 72.56, so I write it in standard form. It will be 7 point, you move one step, it will be 7.256 times 10 raised to power 1. I moved to the left one step, so the logarithm starts with 1 point. So I read the logarithm of 7.256. I read the logarithm of 7.25, and then on the other side of column of 5, and then the other side that is the part of 6, then I add. So it is logarithm, because I shown you on how to read the logarithm from the table, logarithm of 7.256. If I read the logarithm of that, I'll find it to be 0.8607. 0.8607. I'll find it to be 0.8607. You find it to be 0.8607. So if you find it to be 0.8607, that's the logarithm of that. Then I also find 0 point. I go back to 0.64. Logarithm will be 6.4 times 10 raised to power, you move to the right, power of -1, so it will be power 1 point. You read logarithm of 6.4, you read from your table log 6.4, you will find from the table to be 862, 0.862. You will find it to be 0.862. Now because there is a multiplication, I add the logarithms. If I add the logarithms, I get 9. I also get 6. I else get 6 again. I get 16. I write 6. I carry 1 point. Now 1 plus 1 is 2. 2 plus minus 1 is the same as 2 minus 1, which is 1. So I will find 1.6669. So I transfer it here. It will be 1.6. Sorry. I transfer here. It will be 1.669. Now I move and deal with the denominator. Denominator I deal with 1.845845. Standard form remains as 1.845 times 10 power of 0, because you are moving nowhere, power of 0. So the logarithm starts with 0 point. I read this logarithm of from the table log 1.845 from the table, 1.84, and then 5 the other side you add. You'll find it to be 0.2660. 0.2660. Yes, 0.2660. 0.2660. You find 0.2660. Then there is a square. If this number is squared, so you multiply by 2. Multiply by 2. So multiply by 2, you will get it as now whatever I get, I transfer it here. I transfer it this other side. 0.2660. If I multiply by 2, I'll get 0.5532. So I get 0.532 Of course, I add a 0 here. Now, because the two are divided, I subtract. Because this are division, I subtract. After subtracting, I get a 9, I get a 4, I will get a 3, I'll get a 1. 1 minus 0 is 1. I have not found a negative characteristic. If I found a negative characteristic, then okay, now divided by 2, so times a half, the whole thing times a half, because of that square root. So I divide by 2. In this case, because it's a positive characteristic, there is no stress. You just divide by direct. That's 1.1349. You divide by 2 direct. When it's not a negative characteristic, you divide direct. But for a negative characteristics, I showed you on how to do it. So in this case, I'll divide direct. I'll find what? I'll find that is 1.1349. I divide by 2 direct. This gives you 0.50, 0.56. You count 4 significant figures. 0.5675. 4 significant figures, it is 56. Because it's a 4 figure, you are using 4 figure table, so it is 4 significant figures. 0.5675. 75, 4 significant figures. 4 significant figures is 75. So if you find that, so you find the anti-logarithm of this, and the logarithm must be times 10 raised to power of 0. Then you read anti-logarithm of 0.5675. 0.5675. You read for 0.5675. So you find the logarithm of 0.5675. You'll find it to be 3.694. 3.694. 3.694 times 10 power 0. So if it is times 10 power 0, the number remains. So the x is the same. The x is 3.694. It's the same. Does not change. So that is how we apply logarithms. That's how we do using logarithms. Now, as a matter of practice, I will leave you to do the following question for your better understanding and for your benefit. So for your better understanding and for your benefit, and at least to have some challenge, I leave you with this question. I leave you with this question. Evaluate using logarithm of tables. You do this question. A hint I want to give you: when it is addition or subtraction, and you are asking about logarithm, for addition and subtraction, you must first of all do it direct. Like this one, 4.0836 minus 3.7112. First of all, subtract this. What you get, then you rewrite it to be this divided by what you get, so that now you find logarithm using tables after you've done the subtraction. And if it was addition, first of all you do the addition before you start using logarithm, because logarithms we deal with addition, multiplication and division only. So another question that I want you to do is use logarithm to evaluate. You have given this, so already I showed you on how to do. You find the logarithm, that logarithm you multiply by 2, and then you get that logarithm, and also you do deal with these 2 logarithms. You add of the 2 of them, and the other logarithm that you found you subtract. Then the logarithm you find, you divide by 3. If it's a negative characteristic, you remember how to do it. So this you do it. Those are the 2 questions that I want to leave for you, so that you practice. Thank you for listening to my tutorial, and